Welcome back to the channel Unknown Physicist. So today we are in another video of our series Mastering MMP. So for the past 5 videos we were doing complex analysis, and in my previous video we have discussed what is residue theorem. I have done few examples and I have given 12 sums as tasks. If you have not checked that video, please do check and continue with this so that only you will be able to understand the problems which I am going to solve over here. And the solution for the task in the previous video are discussed in the Telegram group, which is Unknown Physicist. You can check your answers over there also. And what we are going to see today is all about contour integration. So this is one of the most important topic in point of any competitive exams. For sure, you can expect at least one question in any exams in this particular topic. So let us see what is contour integration. I will make it easy for you guys. If you are a new visitor to this channel, in this channel I do make videos on different concepts of physics. Right now I'm doing two series. One is quantum mechanics and the other is mastering MMP. So I have done a quite number of few important topics in both the playlist. You can check the playlist and make wise use of it. So let us get started with the video. So before going into today's topic, in last video we have discussed what is residues, and the formula was, if you want to find residue of a function at a point z is equal to a, our formula was 1 by n minus 1 factorial into limit z tends to a d power n minus 1 by dz n power n minus 1 into z minus a the whole power n into f of z. So this is what the formula which we saw in our previous video, and we did quite number of problems over there. So here I am going to discuss a small trick, and this trick is applicable in the case of simple pole. Simple pole means your n should be equal to 1. And one more thing is, your denominator should be a polynomial having factors. So your denominator, I am writing dr, it should be a polynomial having factors. So in that particular case only, this particular trick is applicable. So for example, if my function is f of z is equal to z by z minus 1 into z plus 2. So first, here your denominator are having factors, right? So first find the points at where your denominator will be equal to 0. So at z is equal to 1 and z is equal to minus 2. So here what will your residues? I'm just saying the traditional method what we are doing. So here it would be limit z tends to 1. So I'm doing it for z is equal to 1. So z tends to 1. This would be z minus 1 into z by z minus 1 into z plus 2. Right? So this gets cancelled. You have to apply the limits. It would be 1 by 3. So this is how we saw in our previous video. So here I'm going to share a trick. So let's see what's the trick is. So this is an alternate method. You can say this is an alternate method. Again, this is for simple pole having polynomial. So it is not applicable in all cases. It is only applicable when you have a simple pole having polynomial. Okay. So let me take an example for this. So f of z is equal to z by z square plus 1. So what is your pole here? N, it is 1. So you can apply my trick. So first, before applying the trick, you have to find your singular points. So my singular points would be z is equal to plus or minus I, right? Hope you know how do you find this. So what is the trick I'm saying is, so I have to find at z is equal to I. Let me take this. So my residue of f of z at z is equal to I. Okay. So what you have to do is, you don't need to write the formulas. So you just take and write your numerator. So my numerator here is z. In your question, from your function f of z, just take your numerator and write. And differentiate your denominator. So differentiate your denominator. So it is basically numerator by differentiation of denominator. So if I am differentiating this, I'd be getting 2z. So just apply I for it, which would be plus I divided by 2i. I gets cancelled. So finally your answer is 1 by 2. So if you are using the formula, again you will be getting the same answer. It is just a time saving trick. And for z is equal to minus I. So my residue for the function at z is equal to minus I would be, so take and write your numerator, differentiate your denominator, which would be 2z, right? So if I am applying it, minus I divided by minus 2i. So finally it would be 1 by 2. So you can cross check with the formula also, you'll be getting the same answer. So let me do one more problem. So here f of z is equal to cot z. F of z is equal to cot z. Okay, fine, there is no denominator, but you can rewrite cot z as cos z by sin z, right? So what would my denominator, first I have to find the singular points. So my denominator should be equal to 0. At when z will be equal to 0? So sin z equal to 0. Then my z should be 0 or plus or minus pi, plus or minus 2 pi and so on. So let me take only one point. So residue of f of z at z is equal to 0 would be. So here my pole, okay, I forgot to mention it. My pole here is 1. So I have to just write my numerator cos z, differentiate my denominator. If I am differentiating denominator, it would be cos z. So which would be nothing 1. No need to apply poles also. It is not 1. Hope you got it. So this is not a task, but you can just give a try to these sums. So f of z is equal to tan z. So don't try it with the help of formula. Just try it with the trick what I've shared now. So next is f of z is equal to z by z power 4 minus 1. So I think this sum I have given in my previous video. So you can cross check your answers from there and just try to find answer for this. No need to mention in the comment section. Just do a self-evaluation for you. So this is what the alternate method which I want to share over here. So let's get into the main topic of this today's video.
So in today's video, we are going to see all about contour integrations. So do you have any idea what is contour integration? Actually, contour integration, it is nothing but it is a method of evaluating certain integrals. So let it be a complex valued function, something like that. Evaluating such integrals in a closed path in a complex plane. So what do you mean by complex plane? So which is having a real axis and imaginary axis. So this is what I mean by complex plane. Okay. So how do we have a problem in this case? So which is represented by closed integral f of z dz. So in this the contour will be given in the form of z minus x plus iy is equal to r. So here xy denotes your center point, okay, and r denotes your radius of the circle. So let me state an example which will make you still clear. So if I'm having a contour like z minus 2 plus 3i is equal to 5. So here my radius of circle is nothing but 5 and my center points are 2 comma 3. Hope you got it. So let me state one more example. If contour is z plus 2 is equal to 3. Okay. So in this case radius of circle it is 3. Okay. What is your center points? So if you look at it, here your y is 0. Your x is, if you are taking plus 2, then it is wrong. It should be minus 2. If you are looking into the previous, our general form, there is a minus of x plus y, right? So then your x here it is minus 2. So minus 2 comma 0. So to make more clear, let me state one more example. So which is contour in the region z plus I, 1 plus I is equal to 3. So here my radius of circle is 3. And my center points here are minus 1 and minus, like I square it is minus 1. So hope you got this. So let us still see more clearer.
So a closed integral f of z dz. So you have to evaluate this integral. And the region would be x plus iy is equal to some radius. So first step what you have to find is find the singular points. Find the singular points. You should be very clear with these three steps. So find the singular points. So singular point means your denominator should be equal to, yeah, equal to 0. You have to remember this. And second step, this is the step where most of us makes mistakes. So you should be clear over here. So what is that? Check whether, check whether the singular points, check whether the singular points are inside or outside the contour, whether they are inside or outside the contour. So you have to check. Okay, how should I check it? So for example, if I have a contour which is z plus 2 is equal to 5. So first find the singular points. What are the singular points here? I have not mentioned the question over here. So okay, fine. Let me consider two z points. So for example, if I have a z point as I and one more z point as 3I, and this is the contour which they have defined. So first I have to find whether these points are inside or outside the circle. So first let me find for z is equal to I. So what is the condition? I have to first in this C z plus 2 is equal to 5. For z I have to substitute this. So it should be I plus 2 is equal to 5. So this is inside modulus. So I have to find the magnitude of this. So it should be under root. I square is minus 1, but it is inside modulus. So you should check plus 1 only. So 1 plus 2 square is 4 is equal to 5. And then root 5 is equal to 5. So what is the value of root 5? So it is something 2 point something is equal to 5 it would be. So root 5 here it is less than 5. So your radius of circle is 5. Your radius of circle is 5, but root 5 is 2.5 something. So it is less than. So this point lies inside the circle. So you can choose this. And then next one more point. Okay, let me rub here and write 1 second. So hope I am getting, everyone is getting the point what I am saying. So next point what I said is z is equal to 3I. So I have to substitute that. So this would be 3I plus 2 is equal to 5. So if I am taking finding magnitude, it would be 9 plus 4 is equal to 5. So 9 plus 4 is root 13 is equal to 5. It is not. What is root 13 value? Root 13 should be something 3 point something. So again, your root 13 value is less than 5. So again, this point also lies inside the circle. If you have not understand, let me give one more example which makes you more clear. So let my contour be defined as z is equal to 3. Okay. And my singular points are z is equal to 2I and 4I. So I am considering for example. So I have to substitute over here. So your mod of 2I is equal to 3. So which is what? Under root 4 is equal to 3. Again, 2 is less than 3. So this point is inside the contour. Next is mod of 4I is equal to 3. So which would be? Again, if I am taking under root 16 is equal to 3, which would be 4, 3. So 4 is greater than 3. So this lies outside the circle. So you should not consider the point outside the circle. You should take only the points inside the circle. So let me make it more clear and precise. So first you have to find your singular points. After finding your singular points, substitute them into the contour equation and find whether these points are lying inside the circle or lying outside the circle. So you should consider only the points which are inside the circle. Okay. And then third step, which is the final step. So you have to find the residues of singular points. Find the residues of singular points which are inside the contour or on the contour, which are inside the contour or on the contour. You should not consider the points which are outside. So how should I find the residues? So finally it will be f of z dz is equal to 2 pi I into summation of residues. So we have to do summation of residues of the points which are inside the contour. Okay. So just 3 steps you can do it clearly. So first step is you have to find your singular points, and second step is you have to find whether those singular points are inside or outside the circle, and last point is you have to find the residues of singular points which are either inside or on the contour. You should not find for outside the contour, and this is the final formula to find. So let us solve a few problems so you will be still clear with the concepts. So my first question is, closed integral e raised to z plus 1 by z into dz, and the contour is z is equal to 1. So my first step is I have to find my singular points. So what is my singular point? My denominator should be equal to 0. So my z should be equal to 0, right? So I have to find it whether this point is inside or outside the circle. So C is z is equal to 1. So z is equal to 0. So 0 is less than 1. So this point obviously lies inside the circle. So I can select. And the pole here it is 1. So I have to find residue for this now. So residue of f of z, z is equal to 0. So no need to apply the formula. Just now I gave an alternate method. This is a simple pole and you can use it. So just write your numerator, which is e power z plus 1 divided by, if I am differentiating z, it is 1. So e power 0 plus 1, so your answer is 2. So if you are stopping with this, then your answer is wrong. So finally what you have to do? Integral of f of z dz is equal to 2 pi I into summation of residues, right? So which would be 2 pi I into 2 will be equal to 4 pi I. So this is your answer for your integral. Hope you got the concept. So let me solve one or two problems which will make you more confident. So my second question is closed integral tan z plus secant z divided by z, and the contour is defined by z is equal to 1. So my denominator should be equal to 0. So z is equal to 0. So I have to find whether this is going to lie inside or outside. So 0 is less than 1. So this point is obviously inside the circle. And here it is n is equal to 1. It is a simple pole. So now I have to find the residues. So residues of f of z f of z at z is equal to 0 is equal to, again it is a simple pole. I can apply my trick, which is numerator divided by differentiation of denominator is 1. So it would be tan z plus secant z. So I can rewrite this as tan z plus 1 by cos z. So I have to apply my limits, which would be tan 0 is 0 and then cos 0 is 1. So 1 by 1 it is 1. So finally my answer is 1. You shouldn't stop with here. So your final answer is integral of f of z dz is equal to 2 pi I into summation of residues. So my residue is 1. So your final answer is 2 pi I. Okay. So let me do one more problem. So my third question is closed integral z square minus 3z minus I divided by z minus 2I, and the contour is z is equal to 3. So first I have to find my singular points. So denominator should be equal to 0. So my z value it should be, z minus 2I should be equal to 0. So whereas z is equal to 2I. So next step I have to find whether it is inside or outside. So mod z is equal to 3. So mod of 2I is equal to 3. I have to find the magnitude, which would be under root 4 equal to 3. So 2 is less than 3. So then this point lies inside the, this point lies inside the circle. So next step I have to find the residues. So residue of f of z at z is equal to 2I. Again it is a simple pole. You can use my trick, an alternate method. So z square minus 3z minus I divided by, you have to differentiate the denominator. So it would be 1. So finally I have to substitute for 2I, which would be 2I square minus 6I minus I divided by 1. So this would be minus 4 minus 7I divided by 1. So this is my residue, but I had to need the integral. So for that, closed integral f of z dz is equal to 2 pi I into summation of residues, which is minus 4 minus 7I. So this would be minus 8 pi I. 2 pi I into minus 7 pi I would be plus 14 pi. So this is how we do the contour integration, and you can use the alternate method when you are able to find out a simple pole having a factors in your question. Okay, hope this was helpful. So our video doesn't end with any task, so I have a lot of tasks for you guys. So let us see what are those questions. So this is task. I have a lot of questions, so give a try, sure. So first question is closed integral e raised to 2z divided by z plus pi I. Okay. And I have two subdivisions in this. Okay. So for A it is contour for the region z minus 1 is equal to 4. And for B it is contour is z minus 2 plus z plus 2 is equal to 6. Okay. So second question is closed integral sin z divided by 4z minus pi, contour is within the region z is equal to 1. And then third question is closed integral 2z cube plus 8z plus 5 divided by z minus 2, and the contour is within the region z is equal to 3. And then fourth question is closed integral e raised to z by z into z plus 1 the whole cube, contour is z is equal to 1 by 2. So this is not the end of the problem. I have still a lot more. So we have seen 4 questions. Fifth question it is closed integral e raised to z plus sine pi z by z minus 1 into z minus 3 the whole square, z plus 4, okay, sorry, this is whole square, and the contour here it is, okay, into dz, contour here it is z is equal to 2. Sixth question closed integral z plus 1 by z square minus 9 dz, contour is z minus 3 is equal to 1. Seventh question integral 3z plus 5 divided by z square plus z, okay, it is z square plus z dz, and the contour is z is equal to 1 by 2. Eighth question is closed integral e raised to pi I z divided by z square minus 3z plus 2 into dz, and the contour is z minus 3 is equal to 3. Okay, questions are there. Ninth question it is closed integral z square plus 1 divided by z square into z minus 2 dz, and the contour is within the region z is equal to 1. 10th question is closed integral cos square z divided by z plus 1, sorry, z plus pi by 2 the whole square into dz, and the contour is z is equal to 2. Okay, just few more problems. 11th question it is closed integral cos z power 4, okay, cos z power 4 divided by z plus 2 the whole square dz, and the contour is z is equal to 3. Okay, let me write in the next page. Okay, let me give you still few more. And the 12th question is closed integral e raised to z by z minus 1 the whole square, z square plus 9 into dz, contour is z is equal to 2. And then 13th question is closed integral e raised to z by z minus 1 minus I the whole cube dz, the contour is z minus 1 is equal to 3. And still two more problems. 14th question it is closed integral cos z minus sin z divided by z plus I, sorry, z plus 1, not I, z plus 1 the whole cube into dz, and the contour is z is equal to 2. Last question. So our number of tasks in this video is little bit high, I know, but still, no, don't do it at a stretch. You can take little breaks and do it, but still, solving these many problems, I'm sure this is going to really helpful. And the just exam is scheduled on July 25th, right? So if you are practicing this, sure you can at least hit one question correct in your paper. So that's it. Hope just give a try to these tasks. Hope you have understood the concept. If you have any doubts, don't hesitate to ask in the comment section. Sure, I will be replying you in some time. And for the solution for these tasks will be discussed in the Telegram group. If you want me to make a video for any of the particular questions, sure, I will be doing it in the next video. Hope everyone understood the concept whatever we discussed for contour integral, and still we have one or two concepts left in complex analysis which we will be doing in other two videos, so we'll be completing it. And if you think this video is going to help for anyone's preparation, don't forget to share it with your friends or juniors or college seniors, anyone. And if you want to appreciate the content meant in this video, don't forget to hit the thumbs up sign. So still then everyone, keep practicing and don't forget to complete the task and mention your answers in the comment section or else in the Telegram group, which is Unknown Physicist. So still then everyone, take care, bye bye, have a nice day.